to groundwater for a location over time. It's really, really cool. So this is available to anyone to download. If it doesn't work, you can just email Cole. So bottom left here, ignore the rest of the slide, just look on the bottom left. This is this is actually from a textbook about groundwater in Canada. And what this diagram shows here is runoff. So runoff is how much water, this is sort of generalized, obviously. This is what we think happens to rivers. Runoff is the runoff of rivers in Canada, let's say southern Canada, right? So obviously in the spring, snow melts and rivers, have a large flow, and so the flow in rivers increases, and that slowly drops through the summer, it dries out. Then in the fall, we have storms, we get these tropical depressions that come up through eastern Canada, and then you sort of refill the rivers a little bit, there's a little bit of flooding, and then again this falls, and through the winter, flows drop, and then we repeat this cycle every year. And groundwater, so the water table, this is the depth to water, sort of follows a very similar pattern to the surface water, right? So it rises when all the snow melts, we get the snow melt recharge, it rises, and then we get these storms in the fall, we get sort of a second rise, but not as large as when the snow melts. We see something a little bit different. So this is sort of something that sort of say we need a northern theoretical model. So we sort of proposed up at the top there, this is not published yet, but sort of what we now think is happening, that really everything is dominated by snow melt. Right, so you have all that snow, the snow melts in the Yukon, not all of it, but a lot of it goes into the ground, and it causes groundwater levels to rise. And as groundwater levels rise, that's the single, basically, event that happens sort of a year. For me, at least, I'm like, oh my goodness, this is crazy. This is happening across the entire territory. I've seen more crazy, I think, too, if you look in Northwest Territories, right, where they've had less water, right? The McKenzie River has never been drier. But Yukon right now has this incredible events happening. And we can actually go through and sort of map out where do we find these observation wells that show groundwater flooding. And they're pretty ubiquitous across the territory. So this is sort of this is the ones that had sort of the perfect staircase. I only mapped these up here. So all the up arrows are where we're seeing the staircase happening. Circles are where we don't see the staircase happening. In a couple spots near Kwach'an Lake, we see groundwater levels actually dropped. And that's probably a feature of the lake level itself dropping. So Kwach'an Lake is decrease in terms of
water concentrations, and so you can see there are areas where there's higher concentrations and areas there are lower concentrations, and this is all in streams that have not been disturbed by mining or any other local significant human activity. And I'm just showing that to point out that you get variations in that water quality, and one of the big drivers is the geology. So the map on the other side is a geological map of the area, and in this area we found basically the geology just kind of along the north-south boundary of the Yukon River in that area was more conducive to mobilizing uranium, and so that's why we see some higher concentrations in that area.